Welcome to my channel Mathematics with Sachin Dikshit. This is the 8th lecture on dynamic programming. In this lecture we discuss about application of dynamic programming. The first application, that is solution of LPP by dynamic programming. In previous lecture we discussed some problems of LPP by using dynamic programming. Here also we solve some more examples of LPP by using dynamic programming. First we memorize the points which we have to use in solving of LPP by using dynamic programming. Just revision steps. In general, LPP is maximize z is equals to c1x1 plus c2x2 subject to a11x1 plus a12x2 less than or is equals to b1, a21x1 plus a22x2 is less than or is equals to b2, x1 x2 are greater than or is equals to 0. This is our general given LPP problem. Now to solve this problem by using dynamic programming, we define the function f2 of b1 b2, which is maximum over x2 of c2 x2. That means here first we have to maximize the value of x2, so here we have to denote it as f2. If first we maximize x1, then here we have to write down f1. Just notation part. In this case we take c2 common and we can write f2 of b1 b2 is equals to c2 into minimum of b1 upon a11 b2 upon a22. That means we have to just consider the inequalities corresponding to x2 and just find out the values of x2. If we consider the inequality corresponding to x2, in first inequality we get a12 x1 is less than or equals to b1, therefore x2 is less than or equals to b1 upon a12, hence the first term is like that. And in the second inequality, if we consider the inequality corresponding to x2, we get a22 x2 less than or equals to b2, that is x2 is less than or equals to b2 divided by a22, hence we take these two constants here. Now why we take minimum? These two values, from these two values we have to find out the maximum value which satisfies this condition, and that maximum value is nothing but minimum value of this term, hence this will be converted into that. We discussed this point in more details in previous lectures. Then we have to next come to x1, and for that f1 of b1 b2 is equals to maximum over x1 of c1 x1 plus f2 of b1 minus a11 x1 b2 minus a21 x1. That means from this expression we can write terms of x2, that is b1 minus a11 x1, and from this b2 minus a21 x1. And we have previous the function f2 of b1 b2, and that f2 of b1 b2, this total term is b1 and this total term is now b2, and we have to apply this formula, and that expression can be written as f1 of b1 b2 is equals to maximum over x1 of c1 x1 plus c2 of minimum over b1 minus a11 x1 divided by a21, comma b2 minus a21 x1 divided by a22. That will be the formulation. Just we have to remember these steps and just apply the formula. After simplification, lastly we get the solution of given LPP. We solve some examples to more clear about this idea. First example, solve the following LPP by using dynamic programming method. Maximize z is equals to twice x1 plus 5x2 subject to 2x1 plus x2 less than or equals to 43, 2x2 less than or equals to 46, x1 x2 are greater than or equals to 0. Here in the second constant there is x1 term will be absent. Solution. We have f2 of b1 b2 is equals to maximize over x2 of 5x2. Here objective function there is 5x2, hence we have to write down here 5x2. Take that 5 common, we can write take that 5 term common, we can write f2 of b1 b2 is equals to 5 times of maximum over x2 of x2. Now how to find out this value of maximum of x2? For that, consider the inequalities corresponding to x2. We can write down from this first inequality, we can write x2 is less than 43. Second inequality is purely of x2, therefore we can write down as it is 2x2 is less than or equals to 46. And from these two inequalities can be written as implies that x2 is less than 43 and x2 is less than 23. The maximum value which satisfies these two inequalities is nothing but minimum value of these two constants. Maximum value of x2 satisfying these two inequalities is nothing but minimum value of these constants. Hence, this expression can be written as f2 of b1 b2 is equals to 5 into bracket minimum of 43 divided by 1. That means the coefficient of this x2, that is 43 divided by 1 and 46 divided by 2 divided by 2. This gives the first formulation. Now, next we have the formula f1 of b1 b2 is equals to maximum over x1 of c1 x1 plus f2 of b1 minus a11 x1 b2 minus a21 x1. Here we write f1 of b1 b2 is equals to maximum over x1 of, here c1 x1 means here it is twice x1 plus f2 of, first condition means 43 minus twice x1. In the second condition, x1 term will be absent, therefore b2 will be only present. Here b2 value of b2 is 46. That is, now we convert this f2 of this function into some numeric part as previous one. We get f1 of b1 b2 is equals to maximum over x1 of twice x1 plus 5 times minimum over 43 minus twice x1 divided by 1 and 46 divided by 2. Further simplification of these two terms will be exist and expression will be f1 of b1 b2 is equals to maximum over x1 of 2x1 plus 5 times minimum of 43 minus twice x1 comma 23. Equation number 1. Now simplify this equation number 1. For that, first we consider minimum of 43 minus 2x1 comma 23 is equals to these two values. We take minimum value of these two values is 43 minus twice x1. Let us suppose first minimum value of these two is 43 minus twice x1. Means what? That is 43 minus twice x1 is less than or is equals to 23. Minimum value is 43 minus twice x1 means maximum value is 23. Hence we can write down this expression. Now we simplify this. That is, we transfer this 23 from RHS to LHS, we get, and this minus 2x1 from LHS to RHS. We get 43 minus 23 less than or is equals to 2x1. But what is 43 minus 23? It is nothing but 20 only. The expression is 20 minus 20 is less than or equals to 2x1, that is 10 is less than or equals to x1. That is x1 is greater than 10. Thus, minimum value of 43 minus twice x1 comma 23 is 43 minus twice x1 if 10 is less than or equals to x1 less than or equals to 43 divided by 2. Now this will be the maximum value of x1. From where it will come? Again we consider the inequality corresponding to x1. There are two inequalities in the given problem, but x1 will be present in only first inequality. Therefore, we write the first inequality in terms of x1. That will be twice x1 less than or equals to 43. And it means that x1 is less than or equals to 43 divided by 2. That implies x1 is less than or equal to 43 divided by 2. That means maximum value of this x1 is 43 divided by 2. Hence, we can say that minimum value of 43 minus twice x1 comma 23 is 43 minus twice x1 if the value of x1 is in between 10 and 43 divided by 2. And now consider the minimum of 43 minus 2x1 comma 23 is 23. That means 23 is less and 43 minus 2x1 is greater. That is 23 is less than or equals to 43 minus 2x1. Now again simplify the same procedure. This minus 2x1 is transfer from RHS to LHS and this 23 transfer from LHS to RHS. We get twice x1 is less than or equals to 43 minus 23. That is twice x1 is less than or equals to 20. That is x1 is less than or equals to 10. Thus, minimum value of 43 minus twice x1 comma 23 is equals to 23 if 0 is less than or equals to x1 less than or equals to 10. 0 is least value. We have to given that these values of x1 and x2 they are always positive. Hence, minimum value of x1 is 0. As this expression will be valid. That means we get two terms, two parts of two terms. Then we combine all these terms in equation 1. We can write f1 of b1 b2 is equals to maximum over x1 of twice x1 plus 5 times of is equals to 23 if the value of x1 is in between 0 to 10. Then we get this expression. And 2x1 plus 5 times of 43 minus 2x1 if the value of x1 is in between 10 and 43 by 2. Now first simplify these terms. We can write f1 of b1 b2 is equals to maximum over x1 of 2x1 as it is. 23 multiplied by 5 is 115. That is 2x1 plus 115 if x1 is in between 0 to 10. And multiply 5 to this bracket. We write 2x1 plus 5 into 43 that is 215 minus 5 into 2 that is 10x1. If 10 is less than or equals to x1 less than or equals to 43 divided by 2. Further simplification we get f1 of b1 b2 is equals to maximum over x1 of 2x1 plus 115 if 0 is less than or equals to x1 less than or equals to 10 and is equals to 215 minus 8x1. This 2x1 minus 10x1 that is 8x1 if 10 is less than or equals to x1 less than or equals to 43 divided by 2. Now from this we observe that the maximum value of 2x1 plus 115 for 0 less than or equals to x1 less than or equals to 10 is at. We have to find out maximum value of this term under this interval. If we take x1 is equals to 0, we get its value as 0 plus 115 that is 115. But if we take x1 is equals to 10 that is the highest value of this interval, we get 10 into 2, that is 20. 20 plus 115, it gives 135. That means the maximum value will be exist when x1 is equals to 10. Hence we can write down this statement as the maximum of 2x1 plus 115 for 0 less than or equals to x1 less than or equals to 10 is at x1 is equals to 10. Also, the maximum value of 215 minus 8x1 for 10 less than or equals to x1 less than or equals to 43 by 2 is at. That means again we have to check out this value for the interval 10 to 43 divided by 2. If we put x1 is equals to 10, it means that 215 minus 8 into 10, that means 80. 215 minus 18, again it gives 135. But if we put x1 is equals to 43 divided by 2 in this expression, means 8 divided by 2, it gives 4. 4 multiplied by 43, that gives 172. And 215 minus 172, it gives a number which is less than 135. Hence, the maximum value of this 215 minus 8x1 for the interval 0 less than x1 less than 43 divided by 2 is at x1 is equals to 10. Hence, the value of z will be maximum at x1 is equals to 10. And z max is equals to, that maximum value is 215 minus 8 into 10. That means we have to put that value of x1 in the above two expression. Anyone we can put. Here we put in 215 minus 8x1. That means x1 is equals to 10. Further simplification, 215 minus 80, it is equals to 135. That means maximum value of z is 135 at x1 is equals to 10. Now we have to find out the value of x2. For that, z is equals to twice x1 plus 5x2. Put x1 is equals to 10 and z is equals to 135. It gives 135 is equals to 2 into 10 plus 5 into x2. That is 135 is equals to 10 into 2 means 20 plus 5 x2. That is 135 minus 20 is equals to 5x2. That is 115 is equals to 5x2. Means x2 is equals to 115 divided by 5. That is x2 is equals to 23. Thus, hence, z is maximum at x1 is equals to 10 and x2 is equals to 23, and maximum value of z is 135. That is the first example. Now come to the second example. Solve the following LPP using dynamic programming method. Maximize z is equals to 3x1 plus x2 subject to 2x1 plus x2 less than or equals to 6. x1 is less than 2. x1, x2, they are positive numbers. In previous example, there exists only x2 term. x1 term will be absent in the second inequality. And in this example, only x1 term will be present, x2 term will be absent in this second inequality. In first inequality, both the terms will be exist. x1 is also exist, x2 is also exist. So here we change some change we have to take here. In previous example, first we started with maximum. First we maximize x2 and then come to x1. Here first we come to x1 and then go to x2. We solve it. Check it out. We have in previous examples, first we take f2 of b1 b2. Here we take f1 of b1 b2. That means first we have to calculate these values corresponding to x1. that means maximum over x1 of 3x1 in the constant z is 3x1. Z is equals to 3x1. Therefore, we have to maximize first 3x1. The remaining procedure will be the same. F1 of B1 B2 is equals to 3 take outside the bracket and in the bracket 3 into bracket maximum over x1 of x1. Now we have to find out the maximum value of x1 means what. For that we have to write down these inequalities corresponding to x1 only. In the first inequality we take 2x1 is less than or equals to 6 and second inequality pure x1, that means x1 is less than or equals to 2. That implies x1 is less than or equals to 3 and x1 is less than or equals to 2. The maximum value which satisfies these two conditions means minimum value of this 3 and 2. These 3 and these 2. That is, we have to write down in our numeric formats as f1 of b1 b2 is equals to 3 into bracket minimum of 6 by 2, 2 by 1. This 6 divided by 2 and this 2 divided by 1. That is minimum of 6 divided by 2, 2 divided by 1. Then next we have, in previous example we have to take here f1 of b1 b2. Here f1 we have to find out first and now we come to f2 and therefore the formula for f2 of b1 b2 is general format maximum over x2 of c2 x2 plus f1 of b1 minus a1 to x2 b2 minus a2 to x2. Now we have to apply this formula in this example. Here we have f2 of b1 b2 is equals to maximum over x2 of x2 plus f1 of 6 minus x2 comma 2. In the second expression the x2 value is not present, hence therefore there exists only constant, that is 2. But in the first term we can get x1, therefore here we have to write down as 6 minus x2. Now f2 of b1 b2 is equals to maximum over x2 of x2 plus 3 times minimum of 6 minus x2 divided by 2, 2 divided by 1. Equation number 1. That means we have to take its minimum value and this expression can be written by previous one. Now we have to simplify this. Now consider minimum of 6 minus x2 divided by 2 comma 2 divided by 1. The minimum value of these two values is 6 minus x2 divided by 2, that we have to suppose. That is, this value is minimum, that means this 2 by 1 will be maximum corresponding to this. The expression will be 6 minus x2 divided by 2 is less than or equals to 2. Now cross multiply this 2 on this side, we get 6 minus x2 is less than or equals to 4. Now change that x2 from RHS to LHS and this 4 from LHS to RHS to LHS. We can write 6 minus 4 is less than or equals to x2, that is 2 is less than or equals to x2. 2 is less than or equals to x2, that is x2 is greater than 2. Then the expression can be written as minimum value of 6 minus x2 divided by 2 comma 2 divided by 1 is equals to 6 minus x2 divided by 2 if 2 is less than or equals to x2 less than or equals to 6. Now how to find out this maximum value of x2 is 6? For that again consider the inequality corresponding to x2. There are two inequalities, but in these two inequalities only one inequality which includes x2 and that will be 2x1 plus x2 is less than or equals to 6, is less than or equals to 6. We consider this inequality corresponding to x2. We get x2 is less than or equals to 6. x2 is less than or equals to 6. That means maximum value of x2 is only 6. Therefore, we can write down here 2 less than or equals to x2 less than or equals to 6. And the second part, that is minimum of 6 minus x2 divided by 2 comma 2 divided by 1. The minimum value of these two, now we take it is equals to 2. First we take first value, now we take the second value, that is equals to 2. Now again simplify, if it is equals to 2, that means 2 is less than or is equals to 6 minus x2 divided by 2. 6 minus x2 divided by 2. Cross multiply, 2 into 2 means 4. 4 is less than or is equals to 6 minus x2. That is, now we transfer this x2 from RHS to LHS and this 4 from LHS to RHS. We get x2 is less than or is equals to 6 minus 4. 6, constant number 6 as it is, just change in the variables. That is, x2 is less than or is equals to 2. 6 minus 4 is 2. x2 is less than or is equals to 2. Thus, minimum value of 6 minus x2 divided by 2 comma 2 divided by 1 is equals to 2. Is equals to 2. If 0 is less than x2 less than or is equals to 2. 0, if 0 less than or is equals to x2 less than or is equals to 2, that means the value of x2 is in between 0 to 2. 0 to 2. Now we combine these two expressions. Then equation 1 becomes f2 of b1 b2 is equals to maximum over x2 of x2 plus 3 into 2 if 0 is less than or is equals to x2 less than or equals to 2, and x2 plus 3 into 6 minus x2 divided by 2 if 2 is less than or is equals to x2 less than or is equals to 6. Now we simplify these two terms. We get f2 of b1 b2 is equals to maximum over x2 of x2 plus 6 if 0 is less than or is equals to x2 less than or is equals to 2, and we cross multiply this 2 to this side, we get twice x2. We multiply this to this bracket, we get twice x2 plus 18 minus thrice x2 whole term divided by 2 if 2 is less than or is equals to x2 less than or is equals to 6. Further simplification, f2 of b1 b2 is equals to maximum over x2 of x2 plus 6 first term as it is if 0 is less than or is equals to x2 less than or is equals to 2. In second term, 18 as it is, 2x2 minus 3x2 gives minus x2, means 18x2 divided by 2 if 2 is less than or is equals to x2 less than or is equals to 6. Now we have to find out the maximum terms. Now the maximum value of x2 plus 6 for 0 less than or is equals to x2 less than or is equals to 2 is at x2 is equals to 2. Means we have to put x2 is equals to 0 in this bracket, then we get 6 only. But if we put the maximum value of x2 that is equal to 2, we get 2 plus 6 is equals to 8. That means 6 and 8, 8 is maximum. Hence this x2 plus 6 will be maximum when x2 is equals to 2. Also the maximum of 18 minus x2 divided by 2 for 2 less than or is equals to x2 less than or is equals to 6 is at x2 is equals to 2. Means again we put the minimum value of x2 in this region is x2 is equals to 2 in this bracket. We get 18 minus 2. 18 minus 2 gives 16. 16 divided by 2 it gives 8. And if we put its maximum value that is x2 is equals to 6, we get 18 minus 6, that means 12. 12 divided by 2 gives the value 6. And 6 and 8 is maximum. Hence this function will be maximum when x2 is equals to 2. Hence this function z will be maximum at x2 is equals to 2. And maximum value of z max is equals to x2 plus 6, that is 2 plus 6, it is equals to 8. But now we know the value of x2, we know the maximum value of z. Now just we have to find out the value of x1. For that we have z is equals to thrice x1 plus x2. Put z is equals to 8, put x2 is equals to 2. We get 8 plus thrice x1 plus 2. Transfer these 2 from RHS to LHS. We get 8 minus 2 is equals to 3x1. That is 6 is equals to thrice x1. That is x1 is equals to 2. That means 6 divided by 3, it is equals to 2. Thus, hence z is maximum is equals to z max is equals to 8 at x1 is equals to 2 and x2 is equals to 2. That completes the problem. Now we discuss one more problem. Use dynamic programming method to solve the following LPP. Maximize z is equals to twice x1 plus x2 subject to x1 minus x2 less than or is equals to 1, x1 plus x2 less than or is equals to 3, x1 x2 both are greater than or is equals to 0. We start with the solution. First we have to fix out the value of x1. For that, f1 of b1 b2 is equals to maximum over x1 of twice x1. That one of b1 b2 is equals to 2 into maximum over x1 of x1. Now we have to check out corresponding maximum value of x1. For that, again we start with the we consider the constants and we write the constants in corresponding to x1 only. We get x1 is less than 1 from this equation, and from this inequality we get x1 is less than or is equals to 3. And to find the maximum value of x1 means we have to find out the minimum value of this 1 and 3. Therefore, this expression can be written as f1 of b1 b2 is equals to 2 into minimum of 1 divided by 1, 1 divided by 1 and 3 divided by 1, 3 divided by 1. Hence we write this statement. Now next we know the expression for f2 of b1 b2 is equals to maximum over x2 of c2 x2 plus f1 into b1 minus a1 to x2 b2 minus a2 to x2. This is the formulation. Now using this theoretical formula, we have to apply that to our example. Here we write f2 of b1 b2 is equals to maximum over x2 of x2 plus f1 of 1 plus x2 comma 3 minus x2. In first we have to b1 is equals to 1 and in second equality b2 is equals to 3. Hence we can write down like this. Now for this f1 of this 1 plus x2 3 minus x2, we have to use the previous formula. Here we write f2 of b1 b2 is equals to maximum over x2 of x2 plus 2 into minimum of 1 plus x2 divided by 1 comma 3 minus x2 divided by 1 as previous one. f1 of b1 b2 is equals to 2 times minimum of 1 upon 1 and 3 times 1 upon 3 upon 1, and as like 2 we have to write down here. Now we have to simplify each and every term. This term can also be written as f2 of b1 b2 is equals to maximum over x2 of x2 plus 2 into minimum of 1 plus x2 comma 3 minus x2 divided by 1. We can write down equation number 1. Now we have to find out which value of minimum in these two. For that, consider minimum of 1 plus x2 3 minus x2 is equals to 1 plus x2. That our supposition. If we consider this condition, then what is the range of x2? First we have to calculate that. Minimum of 1 plus x2 comma 3 minus x2 is equals to 1 plus x2. Means 1 minus x2 is less than 3 minus x2. Now simplify this relation. For that, we transfer this x2 from LHS to RHS and 1 from LHS to RHS. We get x2 plus x2 is less than or is equals to 3 minus 1. x2 plus x2 that is equals to 2x2 less than or is equals to 3 minus 1 that is equals to 2. 2 gets cancelled out. We get x2 is less than or is equals to 1. Therefore, we write minimum of 1 plus x2, comma 3 minus x2 is equals to 1 plus x2. If 0 is less than x2 less than 1. Minimum value of x2 is 0, hence we can write this term as 0 less than or equals to less than or equals to 1. Now we consider second part, that is minimum of 1 plus x2 comma 3 minus x2 is 3 minus x2. That is 3 minus x2 is less than 1 plus x2. Again we simplify. We transfer this x2 from LHS to RHS. We transform this one from RHS to LHS. 3 minus 1 it is equals to 2, and this x2 plus x2 it is equals to twice x2. Again 2 gets cancelled out. We get 1 is less than or is equals to x2, and thus minimum of 1 plus x2 comma 3 minus x2 is equals to 3 minus x2 if 1 is less than or is equals to x2 less than or is equals to 3. Now question is how to find out this higher limit. For that, again we consider our inequalities. Given constants inequalities are x1 minus x2 less than or is equals to 1, x1 plus x2 less than or is equals to 3, and we write these inequalities corresponding to x2. We get x2 is less than or is equals to 1 and x2 is less than or equals to 3. Obviously here minus x2 is less than or is equals to 1, and here x2 is less than or is equals to 3 from this relation. That means x2 is less than minus 1, here x2 is less than minus 3. Then what is the higher value? Higher value is 3. Hence we have to write down here higher value of x2, that is 3. That means minimum of 1 plus x2 comma 3 minus x2 is equals to 3 minus x2 if 1 is less than x2 less than 3. Then we combine these two relations. Then equation 1 becomes f2 of b1 b2 is equals to maximum over x2 of x2 plus 2 into 1 plus x2 if 0 is less than x2 less than or equal to 1, and x2 plus 2 into 3 minus x2 if 1 is less than or equals to x2 less than or equals to 3. Now we simplify this bracket. f2 of b1 b2 is equals to maximum over x2 of x2 plus, we multiply by 2, we get 2 plus 2x2 if 0 is less than x2 less than 1, and x2 plus 6 we multiply by 2 in this bracket. 2 into 3 is 6 and 2 into x2 is 2x2. x2 plus 6 minus 2x2 if 1 is less than or equals to x2 less than or equals to 3. Further simplification, f2 of b1 b2 is equals to maximum over x2 of 3x2 plus 2 if 0 is less than x2 less than or equal to 1, 6 minus x2 if 1 is less than or equals to x2 less than or equals to 3. Now, the maximum value of 3x2 plus 2 for 0 less than or equals to x2 less than or equals to 1 is at x2 is equals to 1. How to find out this? Again we have to put the maximum value and minimum value of x2 in this expression. If we put x2 is equals to 0, we get it is equals to 2. But if we put x2 is equals to 1, we get it is equals to 3 into 1, that is equals to 3. 3 plus 2 is equals to 5. And the maximum value of 5 and 2 is 5. Hence, x2 is equals to 1 gives the maximum value of this 3x2 plus 2. Also, the maximum value of 6 minus x2 for the range 1 less than or equals to x2 less than or equals to 3 is at x2 is equals to 1. That means if we put x2 is equals to 1, we get 5. We put x2 is equals to 3, we get 3. Hence, on these two values, 5 will be maximum, and which is at x2 is equals to 1. Hence, we say that this expression 6 minus x2 is maximum when x2 is equals to 1, and therefore obviously z will be maximum at x2 is equals to 1. Hence z is maximum at x2 is greater than x2 is equals to 1. Now we know the values of we find out the maximum value of z. For that we put x2 is equals to 1 in one of the relation. Here we put x2 is equals to 1 in the expression 3x2 plus 2, we get z max is equals to 3 into 1 plus 2, that is z max is equals to 5. Now we know the value of z, we know the value of x2. Now just we have to find out the value of x1. For that we have z is equals to 2x1 plus x2. We know the value of z, we know the value of x2. Put these values, we get 5 is equals to twice x1 plus 1. 5 minus 1 is equals to twice x1, that is 4 is equals to 4 is equals 5 is equals to 2x1 plus 1. 5 minus 1 is equals to 2x1, that is 4 is equals to 2x1, that is x1 is equals to 4 upon 2, that is x1 is equals to 2. x1 is equals to 2. Hence z max is equals to 5 at x1 is equals to 2 and x2 is equals to 1. So from this it is clear that the example will be solved easily, and we can start to solve this example either by using x1 variable or by using x2 variable. These are the reference books corresponding to this lecture. Some more examples on this book you can solve for your further understanding. Thank you for watching this video.